So again, today we're looking at quadratic functions of a polynomial with a degree of 2. So the highest exponent that you see should be a 2. Standard form of that would be ax squared plus bx plus c. Factor form, we're taking those x-intercepts and writing it using a times x minus m, x minus n, so the two places we cross the x-axis. And then vertex form is typically what we would use for transformations. A x minus h quantity squared plus k. So when we look at transforming a quadratic expression, we're looking at the numbers, the coefficients in front of the x squared. We need to look for negatives to identify places that we have a reflection, and then also a shift to the left or to the right. So for g of x, this minus in the front is going to tell us that that's going to reflect across the x-axis. Again, that's because it's technically outside of the parentheses, meaning it's away from our input. We have a horizontal stretch by 2, so this parabola is actually getting wider even though we're multiplying it by 1/2. So just be really careful about whether you're identifying whether the coefficient is between 0 and 1 or greater than 1. And then this 3 at the end is going to shift that vertically 3 units up on the axis. So for h of x, we have a vertical stretch by 3. So again, that's making that parabola look smaller or narrower. This plus 2 that's on the inside of the parentheses is going to shift that graph to the left 2 units. And then the minus 1 is going to be a vertical shift down 1 unit. So two kind of things to remember, and we talked about concavity, so that's that U shape or the parabola, so up like a cup, down like a frown, and then determining whether that would create a maximum or minimum. So a graph that's concave up has a smallest value at the bottom of the graph. Concave down is going to have a maximum, so the highest point that we reach before the graph starts to turn and go the other direction. And then parabolas, we talk about the axis of symmetry, so an imaginary line through the vertex, and we have matching points on either side of that line on the parabola. So to find your axis of symmetry, again, we go back to that standard form of that equation, ax squared plus bx plus c. And the axis of symmetry is that vertical line, so x equals the opposite of b over 2a. So to find the vertex, again, we can use that formula, x equals the opposite of b over 2a. So for this quadratic, a is going to be equal to -3, b is going to be equal to 6, c, even though we don't use it for this, is equal to -5. So we would say x is equal to the opposite of 6 over 2 times -3. So -6 divided by -6 is going to be 1. And then we can take that and we can plug that back into the function rule in place of all of the x values so that we can find the corresponding y value, or the peak or the valley for this quadratic. So this would be -3 minus 6 minus 5, which means that that is going to have the vertex of 1, -14, once we've taken and found all of those calculations. If your quadratic function is already in vertex form, then all we have to do is identify h and k, just being really careful with those minus signs there. Alright, so some ways that we can use and solve for quadratic functions using that vertex. So two numbers have a sum of 10, find the largest possible value of their product. So we want to make sure that we identify our two numbers. So we're adding x and y together to equal 10. And I know that when I multiply and find this product here, that they're going to equal 25. So that's where these two equations come from, here and here. Now, area not area, but the product x times y. Once I have this written as a in terms of the other one, So that's what we did over here. We solved this one for y. Then I can take and I can substitute that in here in place of y. And that becomes, that makes the quadratic function 10x minus x squared. So we use the opposite of b over 2a to solve for the vertex, the axis of symmetry. So we see that's at 5. Once I know that that number is 5, I can solve for the other one by substitution. And then we see that the two numbers are 5. When I multiply them together, the largest product would be 25. So this one's a little bit more detailed. A soccer stadium holds 62,000 spectators with a ticket price of $11. The average attendance has been 26,000. When the price dropped to $9, the average attendance rose to 31,000. Assuming that attendance is linear related to ticket price, what ticket price would maximize revenue? So we actually have to start with this linear relationship. So to find slope. So we find the slope between those 2 points, making sure again that I have the correct attendance number with the correct ticket price. So the slope would be -5 over 2. I need to find the equation of that line. So I use slope-intercept form, plug things in, and solve for the y-intercept. So attendance is given by the equation -2.5x plus 53.5. Now, when a business calculates their revenue, they're taking the number of items that they sell, multiplying it by the price that they are sold at. So again, because ours is changing dependent on this price, we're not writing it as a set value. So the number of tickets is represented by X, and then the number of tickets sold is based on the attendance, which is why we use that equation that we just solved there for attendance, and multiply those together. That, again, generates that quadratic. I would strongly recommend using Desmos to solve this because you're going to get a really large graph and it's really easy to zoom out and find the maximum revenue on that quadratic function. So once you do, you should see that the ticket price of $10.70 is going to maximize our revenue for that company. So the last one, a farmer finds that if she plants 75 trees per acre, each tree will yield 20 bushels of fruit. She estimates that for each additional tree planted per acre, the yield of each tree will decrease by 3 bushels. How many trees should she plant per acre to maximize her harvest? So again, we've got to figure out what this relationship is, this linear relationship. So her harvest is going to be the number of trees times the yield. And so we start by finding the slope. So we see that it's going to be decreasing by 3 every time that I plant additional trees. There's a negative relationship there. So that's our slope. And then we also need to find the y-intercept, which in this case is going to be 245. And so that gives me that equation to represent the yield. So to get harvest, we would multiply x times -3x plus 245. Again, use Desmos to graph this and find that maximum point. So we would plant 40 trees to maximize the harvest. If we plant more than that, then we're actually doing more damage than good to our crops. So again, that's everything we talked about for quadratic functions. Reviewing, making sure you understand how to find max and min, how to find and write equations for application questions for quadratic functions.